Notes 3.1, graphing systems of equations. We're going to solve a system by graphing. And so when they say system, they mean more than one equation. You can see problem number one, you've got two different equations. We're going to graph both of those equations on the same xy axis. So when we start with y equals 1x plus 1, we know how to graph this already. We have a y-intercept number of 1 and a slope of 1. So we go up 1, right 1, up 1, right 1. I would recommend you do a lot of dots. Now it looks like I'm drawing a dotted line. I'm not trying to draw a dotted line. I'm going to fill it in here in a minute anyway. I'm basically drawing the dots. Okay, up 1, right 1, up 1, right 1, up 1, right 1. We're going to have a line. Looks like this. Okay, now we're going to do the same, or we're going to do the next equation on the same xy axis. So we start at the y-intercept of -4, and we give it a slope of -1/4. So down 1 and right 4. 1, 2, 3, 4. Down 1 and right 4. Or up and left. 1, 2, 3, 4. Up 1, 2, 3, 4. Okay. So we've got different points. Now, we don't spend near enough time talking about what we're drawing a picture of, but we are drawing a picture of the solutions. And the red line is a collection of solutions to this first equation. So a line is just a bunch of dots. So you got dot, 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 whole bunch of dots everywhere, everywhere. And then the blue one, we've got same thing. We've got a bunch of solutions to the second equation. So when we solve a system of equations, we want to find any points that would be solutions to both equations at the same time. Usually we're talking about an intersection point. So look at the intersection point right there. It appears that the intersection of the red line and the green line is at -4, -3. -4, -3. So I'm going to label that right there, -4, -3. And that's my answer. That's my solution. Moving on. Number 2, we've got two lines. Should be able to go a little bit faster this time, especially if you know how to graph. Start with the -7, and then we'll go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and over 8. 1, 2, 3, 4, 5, 6, 7, 8. Up 11 and over 8. Looks like that. So use a straight edge if you need to. Whoops, that is not good. That is a collection of points. It's a whole bunch of points that would be solutions to that equation. Now, x equals 8. Remember, here's the x-axis. So if you go to x equals 8, look at the tick mark. We're talking about a vertical line. X equals 8 is going to be a vertical line. Looks like this. Okay, but what is a line but a whole bunch of dots? It's a bunch of points. It's a bunch of solutions, like 8, 0, 8, 1, 8, 2. But we want the solution for both of them. We want a point that's on the red and blue lines at the same time. And so it looks like that intersection point would be the point 8, 4. Look at your x number is 8, your y number is 4. That should be a solution to both of those equations. Moving on, it's more of the same. Start at 7. You've done this before. Down 2, right 3. I would recommend you do it as many times until you run out of room. Up 2 and left 3. Just do it a whole bunch of times. It looks like I only see, 1, 2, 3, 4, 5. You only see 5 dots on the page, but once you draw your line through, please understand, you've drawn an infinite number of dots, not just 5. The 5 that you drew are just the ones that happen to be nice non-fractions. Y equals 5. If you go to y equals 5, that's going to be a horizontal line. So draw a horizontal line. Your solution to the system of equations is that intersection point. So label it on there. That is 3, 5. 3, 5. Or x equals 3 and y equals 5. Next one, a lot tougher because you're going to have to solve or ISO get y by itself. So in the first one, I'm going to subtract this 7x over. Okay, let's do it this way. We've got 7x minus 9y equals negative 18. And if I subtract the 7x, I'll have negative 9y equals negative 7x minus 18. And then I'm going to divide by the negative 9. I get y equals positive 7/9 x, and negative 18 over negative 9 is plus 2. So I'll start at the 2. We're going to go up 1, 2, 3, 4, 5, 6, 7, and over 9. Looks like that. You can go down 1, 2, 3, 4, 5, 6, 7, and over to the left 9. Ugh. We've got a line. Looks like that. You want to be as careful as you can, because sometimes if you make a small mistake, it'll cost you. It'll make your answer wrong. So then we try the other one. 7x minus 9y equals 27. So subtract the 7x. Negative 9y equals negative 7x plus 27. Divide by negative 9, you get y equals positive 7/9 x, and then 27 over negative 9 is minus 3. So start at negative 3, and we go up 7, 1, 2, 3, 4, 5, 6, 7, and over 9. We're down 7 and over 9. So we see two parallel lines. And that should make sense because the two lines turn out to have the same slope. And we learned in a previous lesson that when they had the same slope, they were going to be parallel. But remember the point. We're trying to solve the system of equations, which means we're trying to find points that are on both the red line and the blue line at the same time. I don't see any, and so this one doesn't have a solution. We're going to say no solution because there are no points that are on both lines or solve both equations at the same time. All right, 5 and 6. Here's where the fun starts. You get a new type of equation. The problems number 5 and 6 are circles, and you're going to recognize that when you see the x squared and y squared both at the same time. That's going to be a circle. All right? It's going to be a circle. So this number right here is going to give you the radius squared. So in order to find the radius of the circle, you take the square root of that number. We're going to get, in this case, the radius is 5. Now, the part on the left is what tells you where the center of the circle is. And let me give you the general form. Let me back up a second. The general form of a circle is going to look like this. X minus x number squared plus y minus y number squared equals r squared. You might want to write that down. But what we'll do is we'll do kind of what we did with parabolas and absolute values and think about transformations. Think about shifting left to right or up or down or that kind of thing. So it turns out that this x is shifted 0 and this y is also shifted 0. And so that right there gives me the center of the circle is 0, 0. So you put that together with the information that the radius is 5. And what I'm going to do is I'm going to go to the right 5 from the center. So start at the center. And then go up 5. And then go left 5. And then go down 5. And those 4 points should let you draw a pretty good looking circle. You've got a circle centered at 0, 0 with a radius of 5. So then the next one You look at your transformations, and I like to think of it as what makes 0. But what makes 0 is a 4 and a negative 3. You can think about your transformations if you want, but that's your center. 4 comma negative 3. That's the center of this circle. This number is r squared. So take the square root of 9, and that's your radius. Radius is 3. So from the center point, go to the right 3, up 3, left 3, down 3, and that's going to be a pretty good idea of what your circle looks like. So again, think about it. We're drawing a set of points. Okay, yes, it's a circle, but it's a set of points, and that set of points consists of solutions to that equation. But know that there's a new form. So now we know how to graph lines, parabolas, absolute values, and square root functions, and now circles. So we put it all together, and we're going to have multiple shapes at the same time, which is kind of cool. We can tell this is a circle. It's got a center as 0, 0, and it's got a radius of 3. Remember, square root of that number. So if you go 0, and then right 3, up 3, left 3, down 3, we got a circle. Try to draw a good circle. The better you are, the easier it's going to be to answer the next question. So what we also have to do here is draw a line. This is a line. And we know we start at the y-intercept of 3. And we're going to go down 1, that's the slope, and over 1. And down 1 and right 1, and down 1 and right 1, and down 1 and right 1. Or up and left, up and left. Like that. Kind of a weird thing to graph, but kind of cool as well. We're looking for the points that are on both the circle and the line. And so I see one right here. That would be the point 0, 3. And I see another point right here. That would be the point 3, 0. Pretty neat. Look at number 8. Number 8, the first equation looks like an absolute value graph. So we know this is going to be a V shape. Think about your shifting. We're going left 4 and down 4. So if I go left 4 and down 4, there's the vertex of my V shape. So give it your 1, 1, 1 pattern. So go up 1 and right 1, up 1 and right 1, up 1 and right 1. I would recommend you do a lot of dots so you can draw a good looking graph. Sometimes it's difficult, especially if you're sloppy. If you're careless or sloppy, it's going to be really hard to answer this question accurately. So try really hard to do a good job. Second shape. Do you know what that shape is? It's a circle. We can tell this is a circle. And we can see -4 and +2 is the center. So -4 and +2. And then the radius, square root of 36, is 6. So I'm going to go to the right 6. 1, 2, 3, 4, 5, 6. Okay, good. Up 6. 1, 2, 3, 4, 5, 6. Left 6. 1, 2, 3, 4, 5, 6. And down 6. 1, 2, 3, 4, 5, 6 right there. Interesting. It's kind of hard to draw a good circle. Oops, I missed. That's good there for a second. Okay. But again, the solution is where it hits both red and blue. So I'm going to see 3 separate solutions. Let's name them. This one looks like the point 2, 2. This one where are we at? Left 4 and down 4, so -4, comma, -4. This one looks like left 10 and up 2, -10, comma, 2. So kind of weird. You've got 3 solutions. Let's do one more. I see the first equation looks like a parabola shape. We can see we're going right 2 and down 4. So that means your vertex is at the point 2, comma, -4. Remember the transformations that we've been talking about. So over 2 and down 4, vertex. Parabola has that 1, 3, 5 shapes or pattern, so we're going to go up 1 and up 3 and up 5. If we had more room, we'd go up 7, but I think we're out of room. All right. So as nice as you can. It's really important to do as good a job as you can. Otherwise, you're not going to see where the lines cross. So y equals -x. Think about it as mx plus b. -1x plus 0. We're going to start at 0, and we're going to go down 1 and right 1, and 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 down 1. Okay, like that. Or up and left, up and left. We see 2 solutions. 2 solutions. There's one here and one here. I see this point is 0, 0. And I see this point, what is that? 3, -3. That's it. Solving systems.